my name is George Fazekas. I'm from Queen Mary, just as Mark. And what I'm supposed to do is I'm not giving really an organized talk or anything. I'm just kind of supposed to give a cross-section of what we do at C4DM, mentioning a few other projects apart from the ones that Mark already introduced. And so my research is a bit more on the data and semantic side, and sort of a use of high levels representation of information that you might extract from audio content, and how that information can be used in music production or program making at the BBC, for instance. And one of the first things that I'm going to show is based on the music recommendation technology that was created at C4DM a couple of years ago. I recently, and this was called Soundbites, so this was a little plugin for iTunes which makes you recommendations based on similarity. And so recently this has been incorporated into the BBC Information Archive, and I worked on scaling it up so that it works on 1 million tracks now, rather than just a small personal collection of a few hundred or maybe 1,000 songs. So to give an example of that, let's everybody is mentioning esoteric artists, so let's try with some jazz. So let's play something and see if it's loud enough. Okay, so this is the sort of jazz duo, trio kind of thing. So we'd like to try to find something similar to this. So press the recommend button. It's now searching a database of 1 million songs, and of course it comes up with the same seed song, of course, that's the closest one, and a couple of other things. So let's try to see if this is similar. Probably it is. Okay, starts with piano. Let's see what other instruments are there. Mainly piano. So this is sort of a baseline system we're working on at the moment, which picks on mainly on instrumentation, similarity in sort of same sort of instruments. Let's try a couple of other things. Let's go from jazz to, let's say, rock. Try Dire Straits. Yes. It's probably not going to find it with the typo in it. Let's say, let's listen to this song. I hope it's loud enough.
Yeah.
So, guitars, drums. And Mark Doctor, of course, and let's try to find something similar to this. Okay, so interesting thing, the database, because it's 1 million tracks, it has the same song from different albums. So, brilliant music brains problem. What we can do is we can exclude all versions of the seed song. And let's see what's the closest. Kind of similar. So, similar rhythm. I don't know if it's loud enough actually to hear. Maybe.
Yeah, you can hear.
Yeah. Okay. Bit similar voice. Let's see. Bob Dylan. Well, the computer doesn't really know how to distinguish the subtleties between Bob Dylan and Mark Knopfler, but it's still similar to an extent. So. Yeah, so it can be for that. So this is now trialed at the BBC, and the aim here is to get the system work for BBC producers. So what we're interested in is really to find out what people think and what professional program makers actually think about a system like this. So there's a questionnaire built into this system, and once we have that data, we work towards expanding the types of features that are used by the recommendation engine, because now it uses mainly similarity in instrumentation or acoustic similarity, but we're looking at things like harmonic similarity, rhythmic similarity later on. And at the end of this project, we want to also look into similarity in emotions, and that's sort of a newish field in music informatics or music information retrieval, where we try to associate music pieces with the emotions they elicit in listeners. And so at the end of this project, we are trying to build a system which enables access to these million tracks using emotion tags, or enable similarity matching based on similarity in a sort of emotion representation or emotion space. So a few other things that I wanted to demo includes Catfish Smooth, but Mark already talked about it, so I move on maybe to talk a bit about Sonic Visualizer. So Sonic Visualizer, I think a lot of people have probably seen this tool if you've seen other talks from QM before, but if not, then it's definitely something that worth looking at. So this is not an audio editor, although it looks like one, but it's rather a framework, as Mark mentioned, to visualize the information that can be extracted from audio content. So I just loaded a song. This is from the Dave Matthews Band, and so what you can do with this is, of course, you can play and do some very small editing tasks in the software, but the main feature, which is different from other similar software, is that it runs audio feature extractor plugins, which analyze the audio content and return some structured data about the content, and then you can essentially look at the results. And there are various categories, classifiers, for instance, a segmenter, which looks at things like choruses and verses, but in reality it sort of finds segments of a song which are similar to each other in some sense. It can extract the key of the recording or tonal changes within the recording, a bunch of low-level features like the amplitude or zero crossings. It has a polyphonic transcription plugin, onsets and tempo-related information, and sort of other things which are mainly used for visualization, like constant Q spectrograms, which represent the pitch content collapsed to an octave within an audio recording. So maybe an interesting thing to look at would be segmentation. So I'm going to run this live, and everything, I think this is pretty robust actually, so usually this is not the one that fails. Okay, so change since I plugged this into the projector, probably because of the screen size. So let me just do it manually. So I play this part, which is if I go back to the first one. So this is what I identified as type 1, and then if I go to the other one, which is also type 1, it has the same segment, it has the same lyrics, same sort of instrumentation. But if I try the third one, so now I stop it. So that's quite interesting. If you're interested in look at the sort of analysis that can be done nowadays, then I can recommend to download Sonic Visualizer. It's an open source tool, and download the plugins. There's a website for the plugins. Maybe I should quickly try to show that too. Just typing just to give a brief idea of what sort of plugins are available for this application. So the Queen Mary plugin set has a number of features, mainly the ones that I showed now. Other plugins have transcription, pitch tracking, note tracking, other chord extraction, for instance, lots of low-level features, audio alignment. This plugin is an interesting one because it's a framework developed by another research group in America, but it has a representation within a one plugin, melody extraction, pitch class profiles, onsets again. So there's quite a lot of different types of analysis that you can do with this framework. And if you don't actually want to download anything, but you just want to try out things, and also interested in the sort of structured representations that are needed to encode the information from audio files, you can try this tool called Sonic Annotator Web Application. It is a web-based tool that uses the same plugin framework and the same plugin API for audio feature extraction as Sonic Visualizer. And so if you look at the plugins that are available here, it has more or less the same sort of features that I showed previously in Sonic Visualizer. And what you can do with this tool is to upload audio files. So I'm just going to upload something here. So this one actually identifies the audio files against MusicBrainz and gets all this information from MusicBrainz. And what's interesting, this is using the ontology frameworks that was developed at Queen Mary, and tries to link it up with other information from linked data. And so that's the way it gets to MusicBrainz as well. And then uses this framework to represent the content-based information, so the information that's extracted from the audio analysis using these ontology frameworks. And one of the examples would be to find, for instance, the tuning of the instruments of the recording, also called temperament. So I'm just going to test this. This is a plugin which is supposed to identify the temperament, and since this is just Western pop music or rock music, it's probably going to be something like equal temperament. So what it gives us is a representation of the information extracted from the content in RDF, or using these ontologies. So what we get here is essentially the measurement values on which the decision is based on. And at the very end, we can see that the song is indeed equal temperament, which is not a surprise in this case. But if you're analyzing classical recordings recorded with some sort of historical temperament, then this system will give you other results. So these are the measurement values. Because it's linked with MusicBrainz, we have in the RDF data the MusicBrainz IDs. For instance, we can look at the MusicBrainz artist page. Yes, this should take us to the MusicBrainz page about the Dave Matthews Band, which does work, so that's great. Well, I meant the link, on the linking mechanism rather than MusicBrainz itself. And it also links with other things like DBTune, which is our site exposing lots of linked data about music and the BBC and so on and so forth. So that's Sonic Annotator Web Application. I recommend you to try this out. And what else? Maybe I show something more recent, which is about how to use this kind of structured high-level information that we can extract from audio content in music production. And so this is very recent work and super alpha, so if anything goes wrong, then this is probably the one that will, but let's try. So this is using a DAW called Reaper, and I've got a multi-track project. I think this is a song from Radiohead. The idea for this project was to be able to create audio plugins which are controlled using high-level information extracted from the content, and remember different settings that an audio engineer would put in. So for instance, if you want to use different settings during the chorus or different setting during the verse, then you can basically program a VST plugin using automatic chord extraction, or associate default settings of a plugin with different instruments, which is a common audio engineering case. So this is really an audio engineering application, essentially. So we built this plugin which, so for the moment, the analysis done previously, but in theory it analyzes the recordings and does instrument recognition, automatic structural segmentation, chord recognition, and onset detection. So for now, the analysis is done because it takes a long time previously, so I'm just going to load it. And for every track, it's essentially a multi-track plugin. It recognizes the instrument, so the first one was the bass guitar, the second is a drum kit, the third track is an acoustic guitar, the fourth one is a string instrument, so sometimes it just recognizes instrument families, and you can see that the default settings for each instrument are actually different. And so I could, for instance, pick a chord and say that for the guitar I actually want to emphasize this chord a little bit and change the settings. So what I can do then is, well, I could do this with identifying different segments or onsets or adding chord patterns, for instance. But for the sake of simplicity, I'm just going to show it like this. Essentially, the idea really is to bring together lots of different things from dbpedia. So it includes a couple of other things like recommendations from Last.fm, so it accesses a couple of APIs such as Econest, Last.fm, but most of the information here comes from dbpedia and MusicBrainz, essentially. And MusicBrainz IDs are really key to this application because they are the ones that enable essentially the linking together of the different platforms. So yes, that's pretty much what I planned for today. And if you have any questions, I'm really happy to answer them.